बिस्मिल्लाहिर्रहमानिर्रहीम। डियर स्टूडेंट्स, इसी स्लाइड में हम मिसलिनियस टाइप्स ऑफ डिफरेंशियल इक्वेशन के बारे में पढ़ेंगे और यहाँ जो टॉपिक है इक्वेशंस इमीडिएटली इंटीग्रेबल। A differential equation of the form d square y by dx square is equal to f of x. This differential equation is exact differential equation, hence integrate with respect to x. Integrating this differential equation with respect to x, we get dy by dx equal to integral f of x dx plus c1. If we integrate this second order derivative, we get the first order derivative, and the right hand side will be integrated, and we will put constant of integration. Now this is this is first order differential equation. It is also exact differential equation, integrating again with respect to x. Now if we integrate this equation again with respect to x, so we get y. Integral sign and d by dx will cancel each other. Here we get y, and here we will have the double integral of f of x with respect to x, and integral of c1 is c1x plus c2, and this is the required solution. This is the solution of this differential equation. Here we see the second order derivative, so we have to integrate this differential equation twice, and here this second order derivative is equal to function of x. We have another type of differential equation which will be second order, and here we will have function of y, and for that type of differential equation we will multiply both sides by 2 dy by dx, and we will discuss it in the next slide. Let's finish this slide. So to solve this differential equation, this will be the solution. In case if we have the nth order derivative having the right hand side as a function of x, then we integrate it n times to find the solution. Now we have to take an example of this type. Here we have second order derivative, and here we will have the function of x. So we have an example of this nature. This is second order derivative, and here we have function of x. Solution: integrating both sides with respect to x, so here we will get dy by dx. The integral sign and d by dx will cancel, and here we will get dy by dx, and here we have product rule. Let's this will be the first function, this will be the second. So differentiate by using integration by parts. First function, integral of sine, which is minus cos, derivative of x square, which is 2x, integral of sine is minus cos x plus c1. Now this minus and this minus will be plus. Now here we have integral x cos x. Again using integration by parts, this x will be the first function, this cos will be the second function. So using integration by parts, first function integral of cos, which is sine. Similarly derivative of x, which is 1, integral of cos, which is sine, into dx plus c1. Now this will be simplified here, and integral of sine is minus cos. Integral of sine is minus cos, so minus into minus will be plus, and this 2 will be here, and this c1 will be here. So this is the value of this first order derivative. Integrating again, we have to integrate both sides again. Integral sign and d by dx will cancel each other, and we will get y in the left side, and we will integrate the right hand side with respect to x. So here we see integration of this expression, and this c2 is constant of integration. Here we have product of two function. This minus will be placed here. So first function integral of cosine is sine x, derivative of x square is 2x, integral of cosine is sine x. Now here we have two functions, so integrating by parts, this 2 will be here, integration by parts, and integral of cos is sine x, integral of c1 is c1x and this c2 which is constant integration we placed here. Now this integration of this product is here. Now here we see the product of two functions, this 2 and this 2 will be taken out, and this minus and this minus will be plus. So adding these two terms we get 4 times integral of x sine x, and this 2 sine x will be here, c1x plus c2 will be here. Now these two integration we have added these two terms which are here. Now we have to use integration by parts on these two functions. So first function integral of sine which is minus cos, derivative of x which is 1, and integral of sine which is minus cos. Now here this product will be written here, this 4 minus into minus is plus, integral of cos is integral of cos. So here we see integral of cos, this 4 will be placed here. Now integral of cos is sine x, and these functions will be placed here, all these functions will be placed here, and value of this integral is this one. Now simplifying, this function is here again, it is here. Now this 4 sine x and this 2 sine x will be added together, which is here, and these two terms are here. So this is the value of the integration. That is, it is the general solution of the second order derivative, where we see the right hand side has a function of x. इसी डिफरेंशियल इक्वेशन को जो हमने हल किया तो उसमें राइट साइड में फंक्शन ऑफ एक्स था और यहाँ पे सेकंड ऑर्डर डेरिवेटिव था, तो इसको हमने इंटीग्रेशन बाय पार्ट से हल किया। और यहाँ पे जो दूसरा क्वेश्चन है यहाँ पे फंक्शन ऑफ वाई है, तो ये सेकंड टाइप है। अगर फंक्शन ऑफ एक्स हो तो हमने इसको डिस्कस किया और उस पर एक एग्जांपल हल किया। अब अगर यहाँ पे फंक्शन ऑफ वाई हो तो इसको हम किस तरह हल करेंगे। इक्वेशन ऑफ द फॉर्म वी सी सच टाइप ऑफ डिफरेंशियल इक्वेशन इन डायनेमिक्स। To solve such differential equation, we multiply both sides by 2 dy by dx and get s. Whenever there is a function of y, then we have to multiply both sides by 2 dy by dx, and we see such type of differential equation in dynamics. So let's multiply both sides by 2 dy by dx. Now if we study the left hand side, we see that it is the derivative of this dy by dx raised to the power 2. If we differentiate this expression with respect to x, so by power rule this 2 will be here and dy by dx will be here, and derivative of dy by dx will be d square by dx square. So this left side is equivalent to this one, and this function will be written as it is here. Now integrating both sides with respect to x, जब हम इसको इंटीग्रेट करते हैं तो डी बाई डी एक्स कैंसिल होगा और डी बाई डी होल स्क्वायर हमारे पास ए सिंप्लीफिकेशन आएगा और दूसरी साइड को हम इंटीग्रेट करेंगे। सो लेट्स सी, दिस इज़ द इंटीग्रेशन, और इसके साथ जो डी बाई डी एक्स था वो कैंसिल हो चुका है। अब यहाँ पे क्या है, हेयर वी सी डी एक्स, हेयर वी हैव 2 dy by dx. जब when we integrate this equation, d by dx will be cancelled, and if we have to integrate here, we will put dx here. So dy by dx into dx will be dy. See here, differential of y is equal to dy by dx into dx. So if we study this equation, this dy by dx into dx will be replaced by dy. This dy is dy by dx into dx. Now let's take value of this expression is pi of y, and this is c1. Now taking square root of both sides, now separate the variables. So this is the separation. Now integrate both sides. Integral of d is equal to x. This c2 is constant of integration from which the desired solution. तो यहाँ अगर f of y हो, यहाँ पे सेकंड ऑर्डर डेरिवेटिव हो और यहाँ पे f of y हो, तो इसको हम किस तरह हल करेंगे। तो ये सेकंड टाइप अभी अभी जो हमने पढ़ा ये उसी टाइप पे एक एग्जांपल है। Solve this one subject to the condition y is equal to 0 and your value is 1 when x is 0. This is the initial condition. Multiplying equation 1 by 2 divided by dx we have. जब कभी यहाँ पे f ऑफ y होगा तो हम दोनों साइड में 2 divided by dx से मल्टीप्लाई करते हैं, तो ये आ गया। and this left side is equivalent to derivative of dy by dx whole square, and this function will be written here. This secant square will be written as secant y into secant y tangent y. Now integrate both sides. During integration d by dx will be cancelled and we will get dy by dx whole square, and we will integrate the other side. If we see here, this is f, this is f dash, this is f, this is f dash. So और यहाँ पे हमारे पास फार्मूला है कि अगर इंटीग्रेशन हो एफ ऑफ एक्स का जिसका पावर n हो और ये एफ ऑफ एक्स यहाँ पे एफ डैश की सूरत में भी हो, तो हम इस किस्म के फंक्शन का इंटीग्रेशन लेने के लिए इंक्रीज द पावर एंड डिवाइड बाय द पावर का फार्मूला यूज़ करते हैं। तो यहाँ पे भी f है, यहाँ एफ डैश है। सो इंक्रीज पावर ऑफ सीकेंट y by 1 and divide by the power obtained. Here we have power of secant y 1, so 1 plus 1 will be 2, and secant square y will be divided by 2 plus some constant. अब हमारे पास क्या है, this 2 will be cancelled with this 2, this is the value. Now dy by dx whole square is equal to secant square plus c1. Putting condition y will be 0 when dy by dx is 1. तो यहाँ पे डी बाई डी एक्स इज इक्वल टू 1 है, तो हमने यहाँ पे हम 1 पुट करेंगे, यहाँ पे y हम यहाँ से 0 पुट करेंगे। तो सीकेंड इज एक्चुअली 1 ओवर कास, और कास की वैल्यू कास 0 इज़ 1, कास स्क्वायर 0 इज़ आल्सो 1, सो सीकेंड स्क्वायर 0 इज इक्वल टू 1। तो यहाँ पे 1 आ गया। फ्राम हेयर वी गेट c1 इज इक्वल टू 0, तो यहाँ पे c1 की जगह हम 0 पुट करेंगे। Thus we have, this is the value of this general value. अब यहाँ पे हम क्या करते हैं, टेकिंग स्क्वायर रूट, तो इसको हम इस तरह लिख सकते हैं। अब यहाँ पे हम क्या करते हैं, सेपरेट द वेरिएबल्स वी हैव। सीकेंड का मतलब है 1 ओवर कास वाई, तो इसको हम इस तरह लिख सकते हैं। नाउ इंटीग्रेटिंग, तो इंटीग्रल ऑफ कास बराबर है साइन वाई, इंटीग्रल ऑफ डी एक्स बराबर है एक्स प्लस सम कांस्टेंट। Putting x 0 y 0, this is the initial condition. अगर x 0 हो तो y भी 0 होगा, तो साइन ऑफ 0 इज इक्वल टू 0 प्लस c2, तो ये हमें देता है c2 मसावी 0। नाउ पुटिंग c2 here, so we get sin y is equal to x plus 0. Now shifting this sign to the other side, we get y equal to sin over x. This is the required